thanks for having me here. So we'll jump right in. SIOS Technology is one of the sponsors today, and this is one of our sessions we're glad to be able to present and tell you a little bit about high availability and SANless clustering and what SIOS can do to help you to ensure that SQL Server remains available, whether you're doing on-premise, cloud, hybrid cloud, or anything in between, using our product called SIOS Datakeeper. So before we start, just a little bit about SIOS. We've been around for quite some time, since 1999. I've been with the company 17 years, and we have a worldwide presence with headquarters out in San Mateo and offices across the globe. Like I said, we've been doing this a long time, so we have lots of customers, lots of licenses installed globally. And of course, we're partners with everyone from Microsoft to AWS to Google and a bunch of other people. These are just some of the partnerships we have. And really, as a company, SIOS Technology's full focus is in the high availability disaster recovery space as software developers. So we have solutions for both Windows and Linux for high availability and disaster recovery for all your business critical applications. We have lots of customers across many different industries, but I'm going to just jump right into why you're here, talk the technical part of the discussion, tell you exactly what a SANless cluster is and why you would want to deploy one, how it can help you meet your availability goals, and also help you potentially save money and move to the cloud is another use case we'll touch on as well. So you may or may not know, if you've been around SQL Server for some time, there are at this point really two technologies that provide high availability for SQL Server that Microsoft offers. There's the traditional cluster called SQL Server failover cluster instance. That's been around since SQL Server version 7. And then more recently, as of SQL Server 2012 R2, there's the always-on availability groups, which we'll talk about those solutions a little bit later in the end. But what we're going to focus really on is the traditional SQL Server failover cluster instance, which kind of looks like something like this, where you have two or more nodes, or these are just servers, and these could be physical servers, virtual machine, cloud instances, and they're all attached to a single storage device. So it could be a fiber channel SAN, it could be an iSCSI storage array, it could even be an SMB file share. So any single place where all the nodes are attached, and so that shared storage is where all your databases and log files reside. The problem with the traditional cluster is that shared storage, and again, depending upon whether you're in the cloud or your own data center, or you're looking for hybrid cloud or multi-data center deployments, the shared storage can be a problem. For one, if you don't own a SAN, it could be an expensive proposition. And also, if you're looking for more redundancy, maybe across data center or in a cloud, across availability zone, or even across region, the shared storage doesn't make a lot of sense because it can really only reside in a single data center. So what we do is at SIOS, we eliminate the need for shared storage, but still let you build a traditional SQL Server failover cluster instance. So it's still 100% SQL Server failover clustering, has all the features of failover clustering. It's managed like a regular shared storage failover cluster, and I have a demonstration to show you all this. But the really what it is, it's just a SQL Server failover cluster instance that does not require a shared storage device. Instead, our software called Datakeeper does two things. One, it does block level volume replication to keep the data in sync between all the cluster nodes. So pictured here is just a simple 2-node cluster. So Datakeeper is software that's running on each node, and each node has its own locally attached storage. So the storage can be anything from physical disk, SSDs, flash storage, could be cloud storage, could be virtual hard disk. It doesn't really matter to Datakeeper as long as Windows sees it as a local block device. You attach it, format it NTFS, you give it a drive letter, and then the other nodes in your cluster will have their own storage, same size, same drive letter. And then what Datakeeper will do, it will replicate those volumes from the active node to all the passive nodes, all the remaining nodes. So again, picture here is a two-node cluster where all the writes are occurring locally on node 1 and being replicated to node 2. The replication can be synchronous, which guarantees no data loss, or asynchronous, which is good when you want to replicate longer distance across higher latency networks. But there is a potential amount of data loss in the event of a catastrophic failure. But again, asynchronous is more for disaster recovery, whereas synchronous is going to be used in high availability. Typically, in the same data center, you're going to do synchronous replication. If you're in the cloud, replication between availability zones in the same region will be synchronous. If you want to replicate between multiple regions, then you would choose asynchronous. And so Datakeeper is doing that, making sure the data is in sync across all the cluster nodes. But then it also integrates with failover clustering, so it takes the place of the cluster disk resource. And so when failover clustering detects a failure on node 1, the node 2 will come online automatically, just like a regular cluster would come online. As part of that failover process, the mirror direction is automatically reversed. So now all the writes will occur locally on the disk on node 2 and will be replicated back to node 1 without you having to touch the software at all. It's all part of the automatic failover of failover clustering. And we also support multiple targets. So very commonly we'll see maybe 2 nodes in a cluster in the same data center or in the same cloud region doing automatic failover, but at the same time replicating asynchronously to a 3rd node for disaster recovery purposes. And again, that could be another region of the cloud, could be your own data center, your own DR site. It really doesn't matter. And you can mix. You can do physical to virtual, virtual to cloud, even intra-cloud, Azure to AWS to Google. It doesn't matter because they're all running Windows instances. That's all we care about, is that you're running Windows on the actual instance itself. So you can kind of combine whatever technology you're using to ensure you have availability. And again, this is a mix of synchronous and asynchronous replication. And before I move forward, so I mentioned earlier, there's really two primary choices that you can make when you're trying to configure high availability for SQL Server. The failover cluster instance that we've been talking about is one, and then the always-on availability group. And always-on availability groups, if you're not familiar with it, it's very similar to what I'm talking about here, but it's there's some key differences. One of the differences is that for the full version of always-on availability groups, you need to have the enterprise edition of SQL Server. So it's quite an expensive proposition. Now they do have basic availability groups, so if you only have a couple databases, because basically what the basic availability groups does, it limits you to a single database per availability group. So that it really kind of goes back to the days of database mirroring, where you can't control the failover of a group of related databases, and then each availability group would have to have its own access point, so it doesn't really scale very well. But with the failover cluster instance, you can build a full-fledged failover cluster, a 2-node failover cluster using SQL Server Standard Edition. So you save a ton of money But with SQL Server Standard, you are limited to just 2 nodes in the cluster. So this configuration here, that third node picture, cannot be part of the cluster. However, that does not mean we can't replicate to it. So node 1 and 2 would be part of the automatic failover, and we can still replicate to a third node in your DR site. So your recovery point objective is going to be very good. With the asynchronous replication, we're usually talking about seconds or less of data loss. But the recovery will be more of a manual process where you'll mount those databases, attach the databases, redirect your clients. But that lets you do the high availability and disaster recovery without having to buy SQL Server Enterprise Edition. And there's some other reasons. I'll compare and contrast the always-on availability groups with the SANless cluster at the end of the presentation here. In the cloud, this is pretty much the majority of the opportunities I'm seeing today are people moving to the cloud. Of course, there are cloud services you can use, right? So you can pay Azure, AWS, or Google to run your relational database, right? Whether it's SQL Server or whatever it might be. So there's services out there. We're not talking about that. If your application, can consume those services, database as a service, that's great. Look into that. But if you need to kind of mimic what you have on-prem and you want to run your SQL Server instances in the cloud in infrastructure as a service, you need to assure for availability, right? So the cloud for infrastructure as a service, they give you the building blocks, but it's up to you to actually take advantage of those building blocks to ensure you have high availability. So those building blocks are typically called availability zones or just simple zones. Really, pretty similar across all the major 3 cloud providers. Where if you deploy in 2 instances, if you deploy 2 servers in their cloud and you put those servers in different availability zones, they will, the cloud provider will guarantee 4 nines of availability, or 99.99% service level agreement that at least one of those servers will be online and accessible at any given time. And an availability zone is really just a data center that is well connected to all the other availability zones or other data centers within that region of the cloud. So they will guarantee, again, I call it dial tone, but basically that at least one of those servers, 99% of the time, are going to be available. But they don't guarantee anything about the application running inside those virtual machines. They don't guarantee anything about the data being available in both availability zones. I mean, they do have options for some zone redundancy, but as far as high availability is concerned, it's still incumbent upon you to do something to make sure SQL Server is going to be available for your applications. And again, it comes down to those 2 choices of the SQL Server always-on availability groups or the SQL Server failover cluster instance. So you still have to build out your cluster and to take advantage of the availability zones to ensure that you have a high availability. So it works the same way in the cloud. Failover clustering will detect a failure of the active node and will recover things on the other node, and all that happens automatically. Excuse me. Now, Datakeeper also can work if you have an existing shared storage cluster and you're happy with it, but you're looking to maybe extend that cluster off-site for disaster recovery. You can do that using SIOS Datakeeper, and the software would be running on all 3 nodes here. And so in this case, Datakeeper is controlling the locking between locking of the shared storage between node 1 and 2. So just like a traditional failover cluster disk resource, we will ensure only the active node has access to that shared LUN. And we also will control the mirroring so that when node 2 comes online here, node 2 continues the mirror to node 3 in your DR site. So this is a great, way for you to maybe leverage the cloud for disaster recovery, or if you're building out your own disaster recovery site, you can use Datakeeper to do that. Other than Datakeeper, there are some like array-based replication solutions, but that really isn't viable solution for the cloud. Because you're not managing the storage array typically in the cloud. So Datakeeper is a software solution that lets you do that as well. And so if there's a natural disaster, you can bring things online in your disaster recovery site. So I said I would compare and contrast the two solutions, the SANless cluster, that's the SQL Server FCI with Datakeeper, versus the always-on availability groups. And the big thing out the gates is the support for SQL Server Standard Edition. I mentioned with Standard Edition, you get basic availability groups starting, I think, in SQL 2016, versus being able to build a 2-node SQL Server FCI with Standard Edition. So you're going to save a ton of money. If you don't need Enterprise Edition for anything else, then if you can stick with Standard Edition and Datakeeper, you're still going to save a ton of money, if high availability is the only thing you're looking for. Early on, distributed transactions was a problem for always-on availability groups. They've gotten better over time, so the newer versions will support distributed transactions. But if you have SQL 2012 or 2, there's some limited support. So just be aware of that if you're using distributed transactions. Just keep an eye on the version you're using. The other big thing I see people moving to the cloud, if they have hundreds or even thousands or even tens of thousands of databases, always-on availability groups is just not a viable solution. Each time you add a database or an availability group, it consumes more worker thread processes, and then there's an upper limit in terms of how many databases you can actually protect with always-on availability groups before you run out of resources. With block level replication, we really don't even know how many databases you have, because we're just replicating blocks on the disk. So I'm supporting customers with tens of thousands of databases, and it doesn't matter. There's no limit in terms of the number of databases. So that's probably the second most popular reason people are looking into SIOS SANless clustering solution. Is because the availability groups just does not support their workload. A failover cluster instance, this is true with shared storage clusters as well. It protects the entire instance. So not only are all your user-defined databases protected, but all your system databases. So all your agent jobs, your logins, your passwords, everything fails over together. So a failover cluster instance, when a failover happens, the whole instance fails over, not a small group of databases. It's the whole instance. And so that makes your life a little bit easier in terms of administration. You don't have to, every time you add a database or drop a database, you don't have to configure availability. It's automatically protected as you add it and drop it. And so that, of course, that's going to ease your administration. You don't have to configure any other additional jobs to sync your agent jobs or your logins, passwords, and that kind of stuff. It's all fails over together. And we have no limit. So I pictured 2 nodes and 3 nodes. You can have as many nodes as you like in the configuration. There's no limit. Again, different versions of SQL with availability groups will have a limit in terms of the number of nodes it can support. And then the last thing, finally, is the SANless cluster is great for SQL Server, But really, any workload that you want to protect in a SANless cluster, you can do it with Datakeeper. So in the demonstration here, I'll show you in a moment, we can create a simple file server cluster. We can protect SAP, the ASCS, ERS, Oracle, you name it. Anything that we would normally find in a Windows Server failover cluster, you can build a SANless version of that cluster. And last slide, and I'm going to jump into a demonstration here, just kind of illustrates the cost savings. So I mentioned earlier that, SIOS Datakeeper can be used with SQL Server Standard Edition to build a 2-node cluster. And you can also replicate, to a 3rd node for disaster recovery and not, have to upgrade to Enterprise Edition. So what's pictured here are 3 different configurations. 4-core system, 8-core, 16, and 24-core. And then the blue bar in each column represents the cost of deploying SQL Server Enterprise Edition for the always-on availability groups. It includes the license cost, the software assurance. And this is just, everything here is list price. So, when we get to Datakeeper, that's the list price, and so there's going to be potential discounts, but just for comparison's sake, everything's list price. You get 2 nodes of SQL Server always on with the software assurance, and then the green bar represents 2 nodes of SQL Server Standard Edition plus the Datakeeper software plus the software assurance for SQL Server plus the annual support and maintenance for Datakeeper. And so if you look, even for small configurations, small 4-core configurations, we're going to save you 58%. And you go all the way up to larger, the largest that SQL Server Standard will support is 24-core. And if you have large system like that, you're going to save, 71%. In this particular case, $152,000. And that adds up. I mean, I was just talking to a customer this past month, and I'd say it was. I wish I recorded it. After the end of the demonstration, and I'm talking about this. He's like, "You're going to save us millions of dollars," and that's really not uncommon. If you're talking, that if you run a lot of instances in a large organization, typically is running a lot of instances of SQL Server. If you can stick with Standard Edition, you're going to save millions of dollars. Datakeeper is not expensive. Before I jump into the demonstration here, Datakeeper can be purchased a few different ways. We're in the marketplace in AWS, where you can purchase pay-as-you-go licensing. We also have subscription licenses you can purchase directly from SIOS, or you can buy perpetual license, so yours to keep. Whatever option you choose, it's pretty flexible in terms of if you like to, pay as you go or just want a one-time payment. And the licenses are transferable if you choose to, do the perpetual license and you start maybe on-prem and you're looking to move to the cloud. They're transferable, so that's not a problem. Okay, so I will come back to this. Of course, if you want to learn more, you can go to our website, us.sios.com, the email here. You can reach out to me directly. And I'm going to jump over here to a demonstration, pre-recorded demo, and then I'll save some time at the end for questions if anyone has questions. So let me play this demonstration. So as I mentioned, we integrate with failover clustering. So we're going to start with Microsoft and failover cluster manager. So this runs on any version of Windows, any currently supported version of Windows and SQL Server. So this was released. Datakeeper was originally released when Windows Server 2008 came out, and unfortunately, we still see Windows 2008 R2 in the wild occasionally. We did a big campaign with Microsoft when they were moving people to Azure to get the extended support for SQL 2008 R2. They didn't have a high availability solution, so they partnered with us to provide the high availability for people moving their workloads to Azure. So I have quite a few customers still running those older versions. So that's as far back as we currently support. And then as far forward as SQL 2019, I know Windows 2022 pending to come out. We'll be on top of that soon after its release. But it really, failover clustering has not changed all that much. Obviously under the covers, it's gotten better. There's some features, but the basic functionality, the way the GUI looks and behaves, is pretty identical across the different versions. So I have a 2-node cluster pre-configured here with SIOS 1 and SIOS 2 as my cluster nodes, and I have a SQL Server instance up and running, and you can see it has a typical name, an IP resource, so your client access point. It's also protecting the SQL Server service and the SQL Server agent. Where it's unique here is under storage. Normally you would see something that said cluster disk 1, and instead you see something called the Datakeeper volume. The Datakeeper volume is our own storage class resource type that integrates with failover clustering. It takes the place of the cluster disk resource. So we look at the properties of the Datakeeper volume. We can get information about the replication without even leaving failover cluster manager. So I can see the current source system is SIOS 1, which makes a lot of sense because we're currently online on SIOS 1, and the target is SIOS 2. We're doing synchronous replication. We're currently in a mirroring state. And so it got all that information without leaving failover cluster manager. At this point, it behaves like a regular cluster, a regular shared storage cluster. So if I want to move this workload to SIOS 2, I just do that through failover cluster manager, tell it to move to SIOS 2. And we'll see things start coming offline. And when they start recovering on SIOS 2, you see the Datakeeper volume. It just switched over. It's very quick. It doesn't take but a second to switch the mirror direction. So now all the writes will occur on the S drive attached to SIOS 2, and everything recovered, everything came online. That's nothing unusual. That's what you expect to see with a failover cluster instance. It behaves exactly the same as your traditional shared storage clusters. So that was a planned switch over. Same thing, now we're running on SIOS 2. If that SIOS 2 had a failure, SIOS 1 would automatically recover. And so if I simply stop the cluster service or pull the power cord or whatever failure happens on SIOS 2, failover clustering is automatically going to take action to recover that workload back on SIOS 1. So all this, I did the switch over and then the failback. I never had to touch the SIOS software itself. So once it's configured, again, you just manage it like a regular failover cluster instance. You don't have to do anything special. Now I'm going to show you how to build this. It's very simple. So we'll start the cluster service back up on SIOS 2, and then we'll jump out to the Datakeeper interface. So again, the Datakeeper software is running on both of these cluster nodes, and the interface is very simple, MMC snap-in. This is the job we were just looking at. So again, it's replicating the S drive. It's back now with the sources being SIOS 1, the target being SIOS 2, and it's the S drive. So we see that. The server overview report gives me kind of a picture of the two servers and all the storage attached to those servers. So these servers have a bunch of volumes attached to them. We can see the S drive is already mirroring. So we're going to take one of the other volumes. And again, the only requirement is that the source of the mirror needs to, the target of the mirror has to be at least as big as the source. So if they're same size, it's fine. It's just that the target can't be smaller than the source. So what we're going to do is take the R drive and replicate it from SIOS 1 to SIOS 2. So to do that, it's a very simple 3-step wizard. Once we create a job, we give it a name, we say R drive, optional description, and we'll click create job. Step 1, choose the source, so SIOS 1, choose the volume. You can specify the network you want to use for the replication traffic. In the cloud, it's typically one interface, and that's fine. You can leave it on that interface. And then click Next, and then we choose the target. In this case, SIOS 2 is the target, and all the options are pre-selected for us, so everything looks good here. And then finally, the last screen, we can choose synchronous replication or asynchronous replication. With asynchronous replication, you can also enable compression. So there's 9 levels of compression. That will compress the data before it's sent and decompress it on the other end. So that's going to save on your bandwidth consumption. Again, I've been with SIOS 17 years. So when I first started, people were replicating across WANs that were T1 or T3. There was not a lot of bandwidth, and so compression was very important to save that bandwidth to be able to we were doing a lot of replicating of like Exchange servers and you name it. Now bandwidth seems to be pretty available. Gigabit is pretty standard, and then the cloud between availability zones and regions just really seems to be almost unlimited. But with cloud, you pay for that, right? So you pay for egress and even ingress. You depending on the cloud, you really have to look to see what you're being charged. But by compressing it, you can save money on your consumption. But anyway, you can choose compression, and then there's also maximum bandwidth. It's kind of a bandwidth throttle. Don't use it very often, but again, before bandwidth became readily available, if you were doing the initial replication where you have to do the initial sync, if you had a T1 or even a T3, you could consume that whole the whole WAN, and you might not want to do that. You might want to limit the amount of bandwidth that Datakeeper could use. So you could set a maximum bandwidth, but we're just going to choose synchronous, and that's it. And then we'll click done. So that's creating the mirror. So the R drive is replicating, and then in a moment we'll get a pop-up that asks us if we want to register this in the cluster. So we're going to say yes, put that in the cluster, and then we'll look at failover cluster manager, and we'll see this new volume coming online, this Datakeeper volume R. It's coming online in available storage. At this point, failover clustering treats that like it's a shared disk. So we mimic the shared disk. So if I want to create a SQL Server cluster, at this point, I would run my SQL Server setup, say create a new cluster instance, and walk through the wizard. At the point where SQL Server is looking for the available storage, it will recognize the Datakeeper volume R as an available storage location, and you select it just as if it were a shared disk, and you just finish the wizard. So it behaves exactly the same way. I'm not going to create a new clustered SQL cluster instance, but what I'll do is I'll walk through the high availability wizard for file servers and show you how clustering detects that volume as shared storage. So this is just failover clustering high availability wizard. We're creating a new file server, and all your cluster resources need a client access point, so it consists of a name and IP address. And then this is the important screen where we have to select storage. You will recognize that it recognizes Datakeeper volume R as an available storage location. So just as if it were a shared disk, we'll select it, and that's it. We'll click next, next, finish. And now we have a highly available file server cluster. So that's coming online. At this point, again, you would manage it like it's a regular cluster. And, same with SQL Server. So let me just take a moment now. That's pretty much the demonstration and the presentation. And I'm going to just answer some of the questions that are commonly, people commonly ask me. And then we'll open up the lines if there's any other questions. So Are there any other options besides Datakeeper, right? So in most of my work I'm doing in the cloud, and so in Azure there is they introduced a shared disk. The problem with the shared disk resource is that it's a disk in a single region, and so that means you can't do the multi availability zone deployment. They're introducing some regional replication, but I had to look into it. I still think you're going to have single region for the most part until you have an actual disaster of that. I'm sorry, single zone until you have a disaster of that zone. So we'll get back to you on that. But as of today, it's going to be single availability zone only deployment. Say Azure file shares could be, if you want to use SMB backend. Problem with that is the service level agreement is for is only 3 nines of availability, and so that's not, like I mentioned earlier, when you deploy your virtual machines across 2 different availability zones, you're getting 4 nines of availability. And that, if you're not familiar with the number of nines and what that equates to, so 4 nines of availability basically is less than 5 minutes of downtime per month. I think it's like 4.3 something minutes of downtime per month, which is kind of the baseline for what most people consider highly available or high availability. 4 nines is where it begins. Anything less is not considered high availability. So picking a storage solution that does not even meet the definition of high availability is probably not the best decision that you could make if your job is to ensure the availability of your applications. Moving over to AWS, we have the same situation where we have FSx, which is a hosted SMB share service. Again, 3 nines of availability, that becomes a limitation there. So you're going to want to look into, if you're considering your options in the cloud, just make sure whatever you choose is going to meet your SLA goals and your availability goals. Google, they do have a shared disk. Again, that's limited to a single zone, so it's not really considered high availability because of that single zone deployment. So that's it. So if there are questions, I'm not sure how we do this, if you can unmute your own line or if we have someone moderating. I will take your questions at this point, and we have 15 minutes. So let's do that. Let me see.
We didn't have any questions come in, David.
Okay. All right. Well, I guess I explained it so well. I'll hang out here for a little bit longer if any questions crop up. I think I told you everything I wanted to tell you. I wish I could have been there in person. I miss traveling, but hopefully this time next year, maybe I'll be able to come in person. So
we may do on site next year. We may not. I don't know for sure.
Yeah.
It's in January we'll go. Which how's the lay of the land now?
Yeah, I know.
So, I did enjoy the way in which you explained that you can use the SIOS with standard instead of with enterprise, and leverage the cost savings on the licensing.
That's huge. I mean,
it's massive. I had a firm who literally balked at, we're not spending $250,000 on the requisite number of enterprise licenses. And I said, well, then we're going to, have an outage.
Yeah.
So it's nice to see that there are other solutions to get us through that.
Yeah, absolutely. It's a big chunk of change, and if you can, again, if you're only buying enterprise for the availability features, you're going to want to at least take a look. It doesn't cost anything to take a look at Datakeeper, and I think you're going to be pleasantly surprised at not only the cost savings, but the features and functionality, and knowing it's not, we've been doing it since 1999. This product in particular has been around since the release of 2008.
Yeah.
Has some key people, like even partner like Microsoft, they partnered with us to provide high availability for their SQL 2008 R2 migration to Azure. So if Microsoft can trust us, that's a good endorsement.
Now, and we can also use this high availability in a hybrid environment, right?
Yeah.
Where we're like, one server's prem, one server's cloud.
Yeah, absolutely. Hybrid, anything cross data center, hybrid, your own data centers or across regions.
I mean, that's where AAG, even in the enterprise, falls down. If there's a greater lag than, I don't remember exactly how many milliseconds,
yeah.
It's like, forget about it.
Right. Yeah. So we do, the sync and async, and just like availability groups does that as well. But this, by default, in a failover cluster instance, failover is automatic, regardless if you're doing sync or async. Now, most people will want to control failover, especially if it involves potential data loss. So
right.
We're talking about disaster recovery situation. You can disable the automatic failover by controlling the possible owners of the Datakeeper resource, so that it will never fail over to your DR site unless you actually say fail over. So that's the option. But yeah, hybrid, even cloud to cloud now. I mean, well, we just had I just had a major outage this week. Would have been, for that content delivery, that impacted a lot of people. So people are really, you don't expect a cloud service provider to have a outage that spans, regions, but it's not unheard of. Especially, those types of outages are going to be probably more likely human error than some sort of, weather event or anything like that. So people are they want to have that fail safe. So like, maybe I want to have a copy of my data that's easily recoverable outside of the cloud. And so now we're going to have people that are building, putting maybe their HA in AWS and they're using Azure for their DR node or back on-prem for DR. Any configuration you can imagine is possible. We don't really care. You set up the networking between the two Windows instances, and then that's it. We'll replicate the data. We'll build the cluster. I didn't really even mention it, but the replication engine, it doesn't have to integrate with failover clustering. If you're just looking for a very easy, robust way to replicate a volume from one server to another, then you can use what we call Datakeeper Standard Edition, which is the same replication that comes with the Cluster Edition. It just doesn't include that cluster integration. So it has some, controls in the UI to reverse mirrors. It has command line interface to, do stuff. But it's still a great way to move your data, even to help out with cloud migrations. So people that have very large data sets, they're trying to switch into the cloud, and they're trying to figure out, how can I do this without taking a big outage to copy to restore the last incremental backup, or they're looking for solutions that will minimize the amount of time it takes from on-prem into the cloud. The real-time replication is pretty much when you decide to flip the switch, that's it. Your data is already there. There's no restore time. There's no shipping storage. There's nothing. it's already there. So that's another use case I see, with Datakeeper.
Nice. Okay. Well, thank you very much for this presentation, and thank you for sponsoring.